Hi, Katie. I hope you're having a nice spring break. So let's go through this one that you asked about. So we have x to the fifth plus x squared is greater than or equal to 3x cubed plus 3. So the first thing we want to do is get all the terms on one side. So I'm going to move these terms on the right hand side over here. So we're going to subtract 3x cubed from both sides. And we're going to subtract 3 from both sides. So that's going to give us x to the fifth minus 3x cubed plus x squared minus 3 is greater than or equal to 0. Okay, because they cancel it out on this side, and then I just put them in descending order. Now, the next thing we need to do is find all the zeros. Of this quintic would be the term for something to the fifth. Okay, now we don't have anything like the quadratic formula or anything since it's x to the fifth, so we're going to start by using our graphing calculator. So what I've done is, just so you didn't have to watch me do it, I've already put it in the y equals. So x to the fifth minus 3x cubed plus x squared. Oops, but I put a plus 3 when we want, good thing I checked it, we want this to be subtracting 3. I want that. Okay, so we're going to graph it, and what we're looking for here is where it crosses the x-axis. Okay, so we can see 3 places, here, here, and here, where it crosses the x-axis. Now it looks like -2, -1, and 2. I don't know if those will actually be, so -2, -1, and 2. Now it might be things that, see, it doesn't look like it's quite on the 2, so we can check. Let's go to the table. Sorry, this on screen calculator isn't being super helpful. Another thing we could do, let's use synthetic division. It looks like the -1, it's definitely touching there. So let's do synthetic division there. So we're going to do the little box, put the coefficients, so 1 for x to the fifth, we don't have an x to the fourth, so we're going to do 0. -3 for x cubed, 1 for x squared, 0 for x, -3. And then we'll do synthetic division, so 1, -1, -1, 1, -2, 2, 3, -3, -3, 3, 0. So what this tells us is we now have, so -1, since this was a remainder of 0, -1 is a 0. Because what we're trying to do is make our number line. So we're going to have -1 on there. Now we have x to the fourth, that's a 1x to the fourth, minus 1x cubed minus 2x squared plus 3x minus 3. And we want to know where that's equal to 0. Well, okay, so I paused this for a minute and looked at it. I think this is one of those cases where MathXL, the way they generated the numbers, it's much harder than what I would expect you to do. Because at this point, finding the zeros algebraically is not something that we can easily do. So what I've done, and we'll do an approximation here, is if we find this 0 right here, we see that it's -1.7. Now, you'll see in the MathXL answer that it's square root of 3, or negative square root of 3 is in there, and that's where they get that negative square root of 3. This is actually negative square root of 3. But again, finding that algebraically is much harder than what we've done in this course. Then we would find this 0 over here, and to do that on the calculator, remember you would do second calc sorry, this thing's being buggy. So second calc, what did it do? 0. Okay, so now to do this one, we'd go, we're already to the left of it, but we want to be kind of close to that 0. So there we are to the left of it, hit enter. We'll move to the right of it, hit enter again. And we'll see that's at 1.73, which would actually be the square root of 3. But I would count it right if you just did 1.73. Okay, now we want to know where is it positive. And so one thing you can do, I'm going to put my table on ask. So second table set and put just the independent variable on ask. Okay, because we've got some numbers that are really close together. So we want to know below here, so less than negative 1.73. So we could do something like negative 2. And we're going to put that the number out is a negative number. Then we want something between negative 1.73 and negative 1. That's why we had to change it to ask. We can do something like negative 1.5. So that's positive. Then we want something between negative 1 and 1.73, so we could do something like 0. That's negative. And then we want something bigger than 1.73, so we could do something like 2. It's positive. Now, we're going to look back at our original equation here. We want to know where is it greater than or equal to 0. That means where is it positive. So we want this interval and this interval. So our answer would be, and since it's greater than or equal to, we'll use the brackets. So bracket negative 1.73. Now remember, MathXL did the square root of 3, negative square root of 3, but again, I'm not quite sure how they were expecting you to actually get to that square root value. Up to negative 1. Okay, then union, we're going to pick up at 1.73. They'll have square root of 3, but that's okay. Up to infinity. So that would be our answer. MathXL would have a negative square root of 3 there and a square root of 3 there. But I would give you credit for that. Now, another way that you can see this, once you make your sign diagram, instead of using the table, if you go to the graph, asking where is it greater than or equal to 0 is asking the same as where is it above the x-axis. So we're traveling along, it's below the x-axis until we get to this value right here, which was the negative 1.73. And then it goes up, it's up above until negative 1. So that's our first interval there, negative 1.73 to negative 1. Then it's below the x-axis again until we get to the 1.73, and then it's always above the x-axis. So that's how to see it from the graph. Okay, so let me know if you have any other questions, and I'll see you on Tuesday.